All right, good morning, everybody. We're going to talk a little bit about scale and scale models today. So, you may have heard this before. A scale drawing or a scale model is something that represents an object, too large or too small to be drawn or built to actual size. Okay, so you might draw what it's going to look like, but it's always going to be to scale, which means the proportions on your drawing or model are going to be the same as proportions in real life, so it looks the same, only on a smaller or bigger scale. The scale, in that case, is the ratio. So it ties into the ratio stuff we've been doing. The ratio of the length on the drawing or model to its actual length. Remember, order matters with ratios, right? So ratio is always listed from the model to the actual length. Okay. All right, so here's an example. So you see this on maps a lot of time. It'll have the scale in the corner telling you how far on the map what that relates to in real life. So the key might say this is 1 centimeter to 50 kilometers. Okay, so that's a ratio. So using what we know about proportions, if we knew how far things are on the map, we could figure out how far they are in real life. And vice versa. If we knew how far away they were in real life, we can know how far away they'd be in the map. Okay, because that's just setting up a proportion with one thing to solve for, which we know how to do. Okay, to find that missing measure, and we're going to do that in a second on that example. We're always going to set up the proportion this way, and we're always comparing it this way, model to actual. Okay, this is something we're going to need to be consistent on to make sure we're getting things correct. And this way it's going to be set up every time you see it, so we should get used to seeing it this way. Okay, so the model is the map, toy, or replica. The actual is the real object. Okay, so it's always model on top, actual object on bottom in both of our ratios. So we're going to use what we already know. So when we have a scale, when we're given a scale, that scale already gives us one of our ratios. It tells me that 1 centimeter corresponds to 50 kilometers. Okay, so again, I'm going to do the model on top. The model is how far it is on the map, which is 1 centimeter. The bottom is how far it is in real life, which is 50 kilometers. Okay, so there's my scale. Okay. Now I'm going to fill in what I know from the distance I'm interested in. I know that the two cities on the map were 5.2 centimeters apart on the map. Okay, so I'm putting that on top because that's the distance on the map. Okay, I want to know the distance in real life, so that's the thing that I don't know. Okay, it's okay that these units are different. We just got to make sure they're consistent. So if this is centimeters on the map to kilometers in real life, it's going to be the same thing here. Centimeters on the map to kilometers in real life. Okay. All right, so if I solve this, I can do cross multiplying. X times 1 is just x. That's easy. Equals 50 times 50, 5.2. So if you multiply that, you'll get 260. So if they are 5.2 centimeters apart on the map, that means they're 260 kilometers apart in real life. Okay. All right, let's look at another one. The model Miss Morehouser made of the building she designed is 25.6 centimeters tall. The actual building is 64 meters tall. What is the scale? So here's an example where we're looking for the scale. Okay, so we're given a proportion in real life, and we want to find the scale. Now, when it's asking for the scale, it's asking for how long 1 centimeter on the model represents how many meters on the actual building. These are kind of like unit rates in a way, except instead of the 1 being on the bottom, we're going to have the 1 on the top. So if you're asked for the scale, you generally want to assume that you want a 1 on top. So how much is 1 centimeter or 1 foot or 1 inch or whatever it is in real life? Okay, so we can fill in a 1 on the top of our scale. I want to know what is on the bottom. Okay. So given the measurements we have, we know the model is 25.6 centimeters tall. Okay, so I can fill that in for the model length, 25.6 centimeters. I know that means it's 64 meters in real life. Okay, so here's my ratio from the measurement. Remember, my units are going to be the same. So if this is 1 centimeter, this is going to be something in meters. this is a thing that I don't know. So this is what I'm trying to solve. Again, I can do that again by cross multiplying like I always do. All right, so cross multiplying these, I get 25.6x equals 1 times 64 is 64. And then to solve for x, I'm doing 64 divided by 25.6. So I'm going to use my calculator for that. 64 divided by 25.6 gives me 2.5. Okay, so I know that 1 centimeter on the scale is equal to 2.5 meters on the real thing. Okay, so there's my scale. My scale is 1 centimeter to 2.5 meters. In fact, I shouldn't have just circled that bottom part. Okay, that asks me for the scale. The scale is a ratio. So the scale is 1 centimeter to 2.5 meters. Okay, making sure I'm answering that question. All right, so let's look at another one. It says one of the models of a dinosaur used in the filming was only 15 inches tall. Okay, so 15 inches is the size on the model. In the movie, the dinosaur appeared to have a height of 20 feet. Okay, so here's the actual 20 feet. We want to know the scale. Okay, so remember scale, I'm going to have a 1 on top, kind of like unit rates, but it's on top. I don't know how much, what 1 inch is in real life, or in the movie. So I'm going to have 1 on top. I'm going to use inches. Then it's going to correspond to a certain number of feet on the bottom. Okay, so this will be my x. Set up a proportion. Okay, so set up that proportion. I can do x times 15, that's 15x, equals 20 times 1, which is 20. Numbers are a little bit easier here. Divide by 15. X equals 1.3 repeating. Okay. So here's my scale. My scale is 1 inch on the model is 1.3 repeating feet in real life, or 1 1/3. Okay. All right, so let's now use that scale to keep going. And here we'll round it off to 1.3. That's fine. This will be not exact, but we'll deal with it. So the scale that I just found, because we're using the same scale now, is at 1 inch equals about 1.3 feet. I want to find out if the model had a length of 47 inches, find the actual length. Okay, so 47 is the model length. So I can put that on top, 47 inches. I want to find how far it is in feet on the actual dinosaur. Okay. All right, so using, darn it. All right, so using my cross products, x times 1 is x, well that's nice, equals 47 times 1.3. So using my calculator, I get that's about 61.1. Okay. Oh, leave it there. So it's not asking me for the scale this time, it's finding the length of the dinosaur, so that's 61.1 feet is the answer. All right. So another one. So the Statue of Liberty stands about 305 feet tall, including the pedestal. Ms. Pfeiffer wants to build a model statue, get rid of that at least, that is 20 inches tall. Find the scale of the model. Okay, so we set this up. We know that the model is going to be 20 inches. So remember, model goes on top. And then the actual thing is 305 feet. Okay, so for the scale, remember we want to have a 1 on the top. That's going to be 1 inch. Is going to be a certain number of feet. Okay, so I'm going to to have you pause that here, see what you come up with, and then you can unpause. All right, welcome back, everybody. Hopefully you got 15.25 feet. And so the scale is 1 inch to 15.25 feet. And it's just using our cross products. All right, so I'm going to let you try this one on your own. Using the scale, 1 inch to 15.25 feet. Find the height on the model if the actual height of the pedestal is 154 feet. So I'm going to let you set that one up and solve it yourself, and then we'll check it and see how you did. Good luck. All right, welcome back. Hopefully you got the answer. It's about 10.1 inches. So setting this up, remember our scale for given that is going to be one of the ratios. 1 inch on the model is 15.25 inches in life. Okay. Then we're given the actual height is 154. We know how tall that is on the model. So here's our unknown. Okay. Use our cross products. Okay, so 15.25x equals 154. Again, then we're dividing by 15.25. We get about 10.1. Okay, so hopefully that's what you got. All right, that's all I got for you today, so give that a shot. We're going to talk a little bit about scale factor next time, which is a related idea, but it's going to go just one step further. So don't forget to ask questions if you have them. Good luck.